Okay, in this video, we're going to be, I'm going to show you how to use the StatDisk software to complete StatDisk Assignment number 3. And here I'm using a sample StatDisk Assignment number 3 that I created. For sample problem number 1, part A, you're going to be given a population with a normal distribution, a mean of 0, and a standard deviation of 1. And you're going to find the probability of a value less than 0.4. So the first thing you have to do there is convert the x value to a z-score. Here your x is going to be the 0.4, and the mean is 0, the standard deviation is 1. So you're going to be converting it to a z-score using z is equal to x minus mu divided by sigma. And in this case here, we substitute the x with 0.4, your mu, which is your mean, of 0, standard deviation of 1. That's your sigma. Simplify 0 minus 0 from 0.4, you'll get 0.4. 0.4 divided by 1 will be 0.4. That will be your z value. And now you're going to take that and use StatDisk to enter these in. Okay, so this is what the StatDisk window will look like. Now, the first thing you have to go to is Analysis on the left-hand side. So here, you're going to go to Analysis. Then you're going to select Probability Distribution, and then you're going to select Normal Distribution. And you're going to get this box right here. And you'll be entering one value, then click Evaluate to find the other value. So here the z value that we came up with in the slide was 0.4. So you'll type in 0.4. And then you're going to leave, correction. You want to leave the cumulative area from the left blank. So just be 0.4. And then click Evaluate. Now in this case here, you're going to get this output right here. The z value is 0.4, and here, underneath that is cumulative probabilities, one from the left to the right, two tails, central, and as table A-2. You want to select the one that says the cumulative probability, the one for the left. That would be the answer for the probability of a value less than 0.4, which is in this case 0.6554, if we were to round that off to 4 decimal places. So all your probabilities, you're going to round to 4 decimal places. Keep that in mind when you type in your answer in the actual StatDisk assignment. Okay, so now part B. Here you're given a population with a normal distribution, a mean of 100, and a standard deviation of 15. Here you're going to find the probability of a value greater than 117. So here we need to convert 117 to a z-score using that same formula, z is equal to x minus mu divided by sigma. Your x in this case is at x value of 117. The mu is your mean of 100. The sigma, standard deviation of 15. So 117 minus 100 is 17. 17 divided by 15 will be, to 2 decimal places, 1.13. So we round our z values, always round the z values to 2 decimal places. So it'll be approximately 1.13. Okay, and now we're going to go to the StatDisk. Okay, now in this case here, we're going to do the same thing like we did before. We're going to go to Analysis. Probability Distribution is still going to be Normal Distribution. And the z value this time was 1.13. So we enter that in and then click Evaluate. Okay, so in this case here, your z-value is the 1.13. Now, the problem does say for a probability value greater than 117. So we're going to be looking for the answer that says cumulative probability from the right this time. So the one where it says cumulative probability for the right, which was at 0.129238, that's the one you'll use. But you're going to give that answer to 4 decimal places. So this will be 0.1292. Okay, so less than cumulative area from the left, greater than will be the cumulative probability on the right. That's the difference. Okay, now I'm going to go back to this one. Here's part C. Given a population with a normal distribution, a mean of 98.6 and a standard deviation of 0.62. Find the probability value between 97 and 99. Now in this case here we need to convert 97 and 99 to z-scores. So for x equal 97, we're going to be using z is equal to x bar minus mu divided by sigma. Here your x is going to be 97 minus the mu, which is the mean of 98.6, divided by the standard deviation of 0.62. Well, 97 minus 98.6 will be negative 1.6, and negative 1.6 divided by 0.62 to 2 decimal places will be negative 2.58. Okay, and then for 99, x equal 99, this time it's going to be 99 minus 98.6 divided by 0.62. So 99 minus 98.6 will be 0.4. 0.4 divided by 0.62 will be 0.65 to 2 decimal places. Okay? So now, here's how we use StatDisk to do this. Alright, in this case here, we're going to start with the negative 2.58. So again, we go to Analysis, Probability Distribution, go to Normal Distribution again. Your z-value, we're going to start with the negative 2.58. So we'll enter negative 2.58. And then click Evaluate. Now we're going to look at the one that says cumulative probability on the left. That's this one right here. And that value to 4 decimal places will be 0.0049. That's the one that we will use there for negative 2.58. And now we're going to find the area to the left for 0.65. Type in 0.65 and then hit Evaluate. Now, we want the cumulative area from the left. So we look on the cumulative probability for the left will be 0.7422. If I was to round that off to, in this case, 4 decimal places. Now, we're looking for the area in between the two. So that means we need to subtract the 0.7422 minus that 0.0049. And I'll bring that up again. So it was negative 2.58. And I came up with 0.0049 for the cumulative area on the left. And this was 0.7422, the cumulative probability from the left as well. We'll subtract those two. So if you subtract 0.7422 minus 0.0049, this is what you will get. 0.7373. Okay, so here I'm subtracting those two probabilities there, those cumulative probabilities on the left. Okay, on to sample problem number 2. From a 3M privacy filters poll in which respondents were asked to identify their favorite seat when they fly, n equals to 806, x is equal to 492, who chose the window seat. Okay, there were 806 people that responded, and 492 chose the window seat. Construct and interpret a 99% confidence interval estimate of the population proportion P. Okay, so here we're doing a confidence interval estimate here. So I'm going to X out of these. Now, what we're going to select analysis, going back to StatDisk. We're going to go to confidence interval underneath an analysis. What we're going to select here is proportion 1 sample. Proportion 1 sample. And you're going to get this screen right here. Confidence interval proportion 1 sample. Now we're constructing a 99% confidence interval, so the default is 0.95. We need to change that to 0.99 because 99% as a decimal will be 0.99. And then our sample size, which is our n, and they tell you what n is, that's 806 that responded. The number of successes, which is your x, that was the 492. You'll type that in that particular box. And then click Evaluate. Now here they give you the margin of error, but is this, the one in the middle is the one that you want as your answer. And of course, where it says here, 99% confidence interval using normal approximation, that's the 0.5661771 is less than P and less than 0.6546666. Of course, we round to 3 decimal places. That's going to be, in this case, 0.566, less than P, and less than 0.655. Okay? And now they want you to interpret that confidence interval here. So in this case here, the interpretation is going to be this. And I'm going to go ahead and pull this up. Where it says here that we are 99% confident that the true proportion of respondents who chose the window seat as their favorite seat lies between 0.566 and 0.655. That's the interpretation of the confidence interval here. Okay. And now on to problem number 3. This has 3 parts here. A physician wants to develop criteria for determining whether a patient's body mass index is atypical, and she wants to determine whether there are significant differences between males and females. Use the sample BMI from data set 1, body measurements for males and females on StatDisk. Okay, and in part A, you're going to construct and interpret a 95% confidence interval estimate of the mean BMI for males, and then B for females. Part C, you'll compare the results. Okay, so let's start with part A for males. Constructing and interpreting a 95% confidence interval. Okay, so in this case here, I need to do this. I need the data sets. So I'm going to select data sets. The one that we're going to select is the one that says Elementary Statistics 12th edition. Make sure you select that one. And we're going to select the one that says 1B, body measurements for male. Click on that. And you're going to get this whole screen with all these measurements here. Okay? Alright, now in this case here, we want the descriptive statistics. We need to get that first. So here, I'm going to go to Data. Up here, I need to go to Data. Then I'm going to go down to Explore Data, which is Descriptive Statistics. And then it's going to ask me for which column of data would you like to explore. In this case here, we're dealing with a body mass index here. So I'm going to go to this drop-down menu here and select BMI. Here it is, BMI. I'm going to select that. And then click Evaluate. It's going to give me all of this. But the only thing I'm concerned with is this right here. The box that says Explore Data, column 14, which is your BMI. So here I got the sample mean of 40, sample size of 40. The mean is 26.6005, and so on. All that good stuff is there. Now, you know something else here? Look right here. Competence intervals here. And I think in that problem, in that sample problem, we're doing the, I think a 95%, yeah, it's a 95% confidence interval. So guess what? Here's your 95% confidence interval right here if I can get to it. Here it is. That I have highlighted, that's your confidence interval there. 24.8865, less than the mean and less than 28.314. In this case here, you want to round that out to 3 decimal places here. So it'd be like 24.887, less than the mean and less than 315. Yeah. And actually, the mean, I take that back, the mean, let's say the 2 decimal places here. I think in the StatDisk assignments, they wanted 2 decimal places. So I would say 24.89 as the lower limit and 28.31 as the upper limit here for that 95% confidence interval. Okay? So I'll say that. Round that up to 2 decimal places. Okay? Okay, now, the B part, now I'm going to go back to the PowerPoint, where it says here, construct and interpret a 95% confidence interval estimate of the mean BMI for females. Okay, so now, if I go back to StatDisk, since I have this up, what I'm going to do here is change that drop-down menu. Well, actually, I need to exit out because this is only for males. For females, I got to go back to Data, Datasets, Elementary Statistics 12th edition, and pick the one that says Body Measurements for Females. Okay? Body Measurements for Females. And these are all the body measurements for females here. Okay? And then next, I'm going to pick Data, and then Explore Data, which is your descriptive statistics. And then which column of data I want to explore? The BMI for female. And then Evaluate. So here's all the data statistics there. Now if you look down here, you're going to see your confidence interval for 95%. Okay, so for 95%, let's say the 2 decimal places, that's going to be 26.08, and the upper one will be 30.81. Okay? Because that right there is your 95% confidence interval for the mean. They give you the 95, and then for the mean, and for the standard deviation, and for the variance. We want the one for the mean. Okay? Now, in part C, they want you to compare the preceding results. Can we conclude that the population means for males and females are different? Why or why not? So the ones I have here are for the females. Now, I'm going to go back and do the ones for males. Go to Data, select BMI, and then Evaluate. So the one I have here are the one in front. This is for the males. And this one right here are for females. Now the hint is this. If there is an overlap in those two confidence intervals, then that means we can't make a conclusion about the population means for males and for females. Okay? We can't say that there is a difference between the BMI for males and the BMI for females. Okay? So if you look at that, there is an overlap because this lower limit for females, so 26.076, falls within these two limits for males. So there is an overlap that exists there. So that tells me that we can't conclude that the population means for males and for females are different. Okay? So all of that was sample problem number 3, because you had to do the confidence interval estimate for females and for males. And you have to use the 12th edition of the Elementary Statistics text. 12th edition. Okay, now let's go to problem number 4. As a manufacturer of golf equipment, the Spalding Corporation wants to estimate the proportion of golfers who are left-handed. How many golfers must be surveyed if we want 99% confidence that the sample proportion has a margin of error of 0.025? Alright, in this case here, I'm going to clear this stuff out. Now, what I'm going to do here is go to Analysis at the very top. Go to Analysis. We're going to go to Sample Size Determination. And it's going to be an estimate for a proportion because we're dealing with a population proportion in this case. You're going to get this box right here. So here, you were told we want to be 99% confident. So here, they do give you 0.95 as a default confidence level. We need to change that to 0.99. Okay? So 99% as a decimal, by the way, is 0.99. So I need to change that to 0.99. The margin of error. You were told if we want the population proportion with a margin of error of 0.025, we enter that in. Now, the estimate of P, if known, we leave that blank because we don't know what that is. Population size N, we don't know that as well, so that is left blank. Now we're going to click Evaluate. And at the very top is the required sample size. And that's 2654. Okay? So to answer that question in a sample problem number 4, 2,654 golfers must be surveyed in order to be 99% confident and have a margin of error of 0.025. Okay? And let's go to the last example, which is number 5. And that's this. As a manufacturer of golfing equipment, the Spalding Corporation wants to estimate the proportion of golfers who are left-handed. How many golfers must be surveyed if we want 99% confidence that the sample proportion has a margin of error of 0.25? And this is probably similar to problem number 4. In part A, you're assuming that there are no available information that could be used as an estimate of p hat. The B part, we assume that we have an estimate of p hat found from a previous study that suggests that 15% of golfers are left-handed. And part C, does the additional study information from part B have much effect on the sample size that is required? Okay. So if this helps, I would go do this over. Here you go to Analysis, go to Sample Size Determination, and then Estimate Population Proportion. You'll get this screen, and we're talking about a 0.99% confidence, so it'll be 0.99. Go down the margin of error, that would be 0.025. We know nothing about the estimate of P, so we leave that blank, and we leave the population size blank. And that will be your required sample size again, 2,654. Okay? Now the B part, we're assuming that we have an estimate of p hat found from a previous study that suggests that 15% of golfers are left-handed. So in this case here, we're still using the same 99% confidence level, the same margin of error of 0.025, but now we have an estimate of P. We can enter that in. 15% as a decimal will be 0.15. And then you're going to click Evaluate. And notice in this case, that sample size is smaller. It's now 1,354. Okay? 1,354. So now in part C, we're asked, does the additional study information from part B have much effect on the sample size that is required? Well, with that additional study information, the required sample size has been reduced. Here we end up reducing the sample size by providing that additional study information. Okay, so this should help you with the actual StatDisk assignment that you're required to complete by the due date indicated on MyLabsPlus. All right, please email me or call me if you have any questions about the assignment. I'm here to help.